Alright guys, so let's get started with our lesson on strings. The first question here is, in Java programming, what is a string? So you might already know this because we've kind of touched on strings in various assignments in the past, but today we're going to officially bring it up and do a deeper dive into strings. So I will answer my own question here. So a string is a variable, right? But it's different than other variables we've worked with in the past. That's why it kind of deserves its own section, I guess. It's a small little topic unit on strings. So it's a variable that holds words, text, and non-math numbers. Okay, when I say non-math numbers, I mean things like credit card numbers and things like that. Typically, those aren't numeric. They're called strings because we don't do any math on them. Like you never find out the average credit card number or the highest or lowest number, those kinds of things. Plus, making them strings, we can do a lot of encryption on credit card numbers, which is kind of a big deal in the internet these days. Okay, so some examples could be things like, like your username or your password, right, or an email address. Also, like I'm going to put credit card number down just because that's a good example of a non-math number. Okay, so these are all things that would be considered strings. Also, I'm going to add up here all data is stored using double quotes, like that. Okay, so that's when you put that around something, then Java knows it's a string rather than a number of some sort. Or a single quote, because remember, single quotes are for chars, so double quotes are for strings. All right, so I'm just going to come over here to my string sample that we kind of started, and I'm just going to create a string. Okay, so I'm going to go string x equals the quick brown fox, and that's because that's the example we're going to be using in this note. Quick brown fox. Okay. So this next question, unlike other data types in double string, char, boolean, string is not a primitive data type. So remember we've talked about primitive data types, or at least I've been kind of banging it over your head for a couple of months now. Remember, a primitive data type, it can only do one thing. It can only hold a piece of data, and that's all. But in addition to holding words or usernames, whatever, strings can do a lot more than that. Okay, so for example, if I come over here and I just go like this, I'm going to have another variable, first of all, int y equals 10. Okay, so now we have a primitive data type y and we have a string variable, which is x. Okay, so if I go like this, x dot and control spacebar, I get this whole menu of the things that a string can do. So these are all abilities that a string has. And remember, primitive data types don't have abilities like this. Now there's a huge list of things you can do with a string. Now we're only going to cover like the top 5 or so, and not kind of go through every single one of these, because honestly I don't use a lot of them. But they are handy, some of them. So we're going to go through the most handy of the string methods. Okay, these are called methods, by the way. These are all, you can think of them as abilities or things that a string can do. Okay, so that's not primitive because it can do a lot of things, right? Just like C dot, like C is a console, it's also not primitive because I can go control spacebar and here's all the abilities that a console has. Now if I try to do that on int y control spacebar, I get nothing because y can't do anything other than just hold a value. Okay, so that's one thing. Let's just put that in here as part of our answer. Okay, so there's two things about strings that tell you this. One, it has abilities, right? In other words, things it knows how to do. Okay, these are also known as AKA methods. Okay, so a method is like basically an ability or a command that it can understand. Okay, and we're going to look through some of those abilities down here. The second thing about it, and this isn't quite as big of a thing, but something you should notice, okay? The string data type is capitalized. Okay, so it's an object just like anything else. Okay, so for example, like console C, right? What I mean by that is like I don't go console C with a small c. Okay, that's going to give me an error. Same with string, small s string. Okay, small letter means primitive. Okay, and neither of these are primitive, so you gotta name them. This is a data type. So the data type of C, or the kind of variable C is a console. The kind of variable that X is, we call that the data type of X, is string. Okay, I don't go capital I int on this one because int is primitive, and so it does get the lowercase. Okay, so lowercase, and the other ones are like that too for primitive, right? Like we have double and we have Boolean, right? So we've learned all these in the past, but they're all lowercase, right? Meaning that they're primitive. Okay, so that's just a small other distinction. But other than the primitives we've looked at, everything else is basically some kind of an object that has abilities, so it's going to have a capital letter. All right, so those are the two things that tell you that X is not a primitive data type. All right, so I've already got my X variable, the quick brown fox, and so we're going to use that for some of these abilities or methods down here. So when you look at something like the quick brown fox, here's what Java sees. What Java sees is basically a list, almost like an array. So in the last lesson from last week, we talked for a little bit about arrays, where you could have a variable that holds a list of things, like a list of marks, or a list of subjects, and those were strings as well, or even like a list of checkboxes, like we did the checkboxes for the 4 of a kind, right? So you can have a list of just about anything you want to. So in Java, basically a string is seen as kind of a list of characters, okay, or a list of letters. Okay, so this little chart here, and just like a list, it starts at 0. So the capital letter T is in position 0, right? And then it goes 1, 2, whoops, 1, just hit tab, 2. Even the space between words, that's also a character. It's just the spacebar character, but that counts as well. Okay, so I'm just going to go through and I'm just going to mark this up. This is just going to help us keep track of what it's doing a little bit more easily. 11, whoops. Try that again. This part is not hard. I just got to make sure I'm doing it right. So I'm just hitting the tab key here, guys, to go to each little box. 15, 16, 17, 18. Okay, now as users of Java or as programmers of Java, we don't actually see these numbers, right? But just know that they exist in the background. All right, and as we get into some of these different methods down here, then you'll see where these numbers come in handy. Okay, so instead of the word, well, I've got phrase everywhere, so maybe I'll change this here to be phrase as well. Okay, because I want to also actually do some of this code in this sheet just to sort of show you how it actually works. Okay, so the first one is int len equals phrase.length. So I'm just going to write that here. Okay, and you can type along with me in your code as well. So I'm going to go int len equals phrase.length. Okay, and then on the next line it says c.print length of phrase len. So c.print length of phrase plus len. All right, so we're printing the length out. So, and that's, pretty obvious what that does. It gives you the length of the phrase. Now, remember, it goes from 0 to 18, right? So the last spot is 18, but because it starts at 0, the entire length, the number of letters and spaces, is actually 19, right? But we're numbering at 0 to 18. So when I run this, that's what I should see. The length of the phrase is 19. Let me just quickly give this a run here. Right, so the length of the phrase is 19. All right, so we'll put that in here as our answer. Okay, the length of the phrase is 19. Okay, so that's the first method, the length method. Okay, there's also a substring method. Okay, and it basically slices the string up and gives you part of the string back. So 0 to 9, you're supplying the start and the end. Okay, so it's basically going to take this chunk here, and it's going to make a string out of that. Okay, so I'm just going to put that as my next little thing here. So I'm going to say string first part equals phrase dot substring from 0 to 9. Okay, and then I'm just going to print that. So I'm going to go c.print line first part. Okay, so if I compile and I get a mistake here because I made a typo. There we go. Let's try that again. Compile and run, and it's going to give me the quick. Okay, so there's the quick. Okay, so as we do these, we'll just kind of put in our results down here. In the end, guys, I'm going to have you submit both the program and the sheet just to show that you did both. All right, now just before I go on to 2 uppercase, which is kind of self-explanatory, I want to just sit on this substring just a little bit longer because it can be a kind of confusing thing. This 9 here is not included in what I get back. Okay, now you can't really tell that because it could be there, it couldn't be there. We don't really know because it's a space either way. But let me change it to like 0 to 6. Okay, so 0 to 6, you'd think you're going to get the QUI. Okay, but the last number is not included. It's everything up to but not including that last number. Okay, so if I change it to 0 to 6, I'm going to get the QU. Okay, I'll just show you that really quickly here. 0 to 6, right? And I'll just compile and run it here, and you're going to see the QU. Okay, so it's just a little gotcha, something that is easily mistaken, right? So there you see it there. Okay, I'll put it back to 0 to 9, but just know that it doesn't include a space after the quick. All right, so let's go on to the next one, and we'll compile this again. So to uppercase, obviously that's going to give us back the entire thing in uppercase Fox, quick brown fox. So all in uppercase. Of course, it's not going to misspell it like I am here. Okay, so the quick brown fox, right? So we'll just do that here. So we'll create another variable called upper, right, which equals the phrase dot to, and you can always go Control Spacebar, and you can just pick it from the menu if you don't feel like typing the whole thing out. So there it is there. If we want to see it, then we have to print it still, right? So I'm going to go c.println upper, right? And then if I compile it again, you'll see the results of that. So there it is in uppercase. Okay, there's also a lowercase, so you can also change it all to lowercase as well. So maybe we'll put that down here as well. Okay, so maybe just in brackets here, just to remind yourself. Also, a to lowercase. Okay, now this can come in really handy. Like if you don't really care about case, like upper lowercase, when people enter like some kind of a reply, and you want it to count either way, then you can convert it, everything they enter, to lowercase or to uppercase. That way you know that it's not case sensitive anymore. So this is a little thing. It's kind of handy in certain situations where you need to do that kind of thing. Okay, so we have a couple more here. Index of will find out the location of the first instance of the thing you're searching for. Okay, so C is at location where's C. So it's going to go through here, and it's going to find C at location 7. So it'll say C is at location 7. Let's just try that really quickly. So I've got a variable called where's C. Where's C? Kind of like where's Waldo, I guess. So that's going to be phrase dot index of the letter C, right? And then I'll just go c.println C is at location plus the variable where's C. Okay, so it should say C is at location, what do we say, 7, 6, 7. So I'm going to compile that, and you'll see that here. Okay, so C is at location 7. Okay, a couple more things about this that I want to, let me just put the answer in first. So C is at location 7. Okay, you can also use index of to find like where does brown start. So index of brown will give me the location 10, because that's where the word brown starts in this string. Okay, so I'll just change that. I'll say index of brown. Okay. Okay, so let me spell that right. Brown. Okay, so I'm going to say brown is that location. Okay, and I won't bother to. Oh, I have a hard time with the word brown today. I won't bother to change the name of the variable. But now, because brown starts at 10, it's going to give you like the starting point of where it finds that substring, I guess. That's that string within a string. Okay, so now it should say brown is at location 10. Okay, so we can use index of not just to look for letters, but to look for words within the word. Okay. Now, what happens if we don't find anything? So I'm going to go Z. So index of Z, and there is no Z in this string, right? So what happens? Well, if it doesn't find the location of it, it gives you back a -1. Okay, so a -1 is your clue or your cue that whatever you're looking for was not found. Okay, so Z -1. Okay, so a couple of things there. Okay, so I'm not sure if we can fit that in here or not. I'll try. Can also look for words. Okay, and maybe up here I'll say -1 equals not found. Okay, so that kind of summarizes what I've been trying to show you with the whole index of thing. All right, so Because this is like a, whoops, where'd it go? Because this is like a list of letters in a string, we can actually use a for loop to travel through each letter at the time, or at a time if we want to. Okay, so for example, I can go like this: for int I equals 0, I less than phrase dot length, right? Because we don't know necessarily how long it is, but if I say less than phrase dot length, it'll go to the end of the phrase, and I'll just say like I plus plus, right? So we've learned about for loops recently, and we use them for different things, including traveling through an array, which we're going to look at in more detail in future lessons. But for today, we can also use a for loop just to travel through a string, one letter at a time. Okay, so we can sort of use like the char at. Did we do char at yet? I don't know if we did. No, I guess we're learning char at here. Okay, so char at is basically, give me the character at that location. All right, so if I go like this, c.println, give me a plus phrase dot char at I. Okay, so it's going to say, like, it's going to go, give me a T, give me an H, give me an E, give me a nothing, give me a Q, give me a U. Okay, so it's going to basically travel through and extract the character at each location. Okay, and the location is going to go from 0 to 19, or 18, I guess, and give me each letter one at a time. Okay, so that's not what this program here does, but I just wanted to show you an example of using a for loop to travel through a string. Okay, we're actually going to use this, like next week we're going to do like a game of Hangman where you guess a letter to see if that letter's in the word, which is kind of like Wheel of Fortune, I guess, same idea. So this is how we're going to do it. We're going to travel through the string, and every time we find, like, say, an A or a vowel or whatever, a T, we're going to basically turn that letter over and reveal that as part of the solution. So this is the way we can do it. We can just travel through one letter at a time, and if we match that letter, then we can turn it over, like as a tile or something in a P applet. But that'll be for next week. But anyway, I just want to show you this little simple example for now. So if I run this, you're going to see this whole bunch of thing come up on the screen. There it is. Give me a T, give me a H, give me an E, all the way down. Okay, so we're extracting each letter at a time using the char at. Okay, now what is this program doing? Well, this program's actually going backwards from the end, which is, you don't want to go length, we want to go len minus 1. Right? Remember, len is our variable that keeps track of the length, but we don't want to actually go to 19 because there is no 19, it starts at 18. So we're going to start at len minus 1, which is 18, all the way back to and including 0 and going minus minus backwards through the list. So what we're doing, guys, is we're starting with a new string B, and we're extracting each letter out of the phrase one letter at a time, going backwards. Right? So in the end, if you haven't guessed it already, this is going to basically, B is going to be phrase only spelled backwards. Now, I'm not sure how well you are at spelling backwards. I know it's hard for me. So I'm going to go XOF, I'm going to try my best here, space NWORB, my brain's hurting, KCIUQ, EHT. There we go. Okay, so it basically produces the backwards of that. Okay, so let's modify this little loop I did here and do that. Okay, so we need another string up here, which I'm just calling B, I guess, for backwards. Okay, now it's important that we start this out as two quotes, okay, because we're going to add on to it. So you guys know how plus equals works. Like if I say something like score plus equals 10, right? So we're saying increase score by 10. Okay, but we can also use plus equals for strings. So I can go like B plus equals pi. Okay, so I'm saying basically tack on the letters HI to B. So plus equals to a string means add these letters to the string. Okay, so just like integers and scores, we have to initialize it. So by saying add on to, we're saying increase it by these letters. But that means B has to have a starting position. So we start B as a starting position of quote, quote. So it's an empty, we call this an empty string. Okay, so you can put that there if you want to. So it's an empty string, no letters in it at all. The length of it is 0, okay, because there's nothing in there. But then we can at least go plus equals to build on to an empty string. Okay, so that's why I have to initialize it or give it a starting value of two quotes. All right, so let's just go back through here. And with this for loop, instead of starting at 0, we're going to start at 18. Or we can start at len minus 1. Okay, so that works the same way. Because we're going backwards, we got to flip this around. Okay, and we're going to say greater than or equal to 0. Get rid of this. And we're going to say I minus minus. Whoops, there we go, and I minus minus. All right, and then all I'm going to do in here is I'm going to tack on, I'm going to say like B plus equals phrase at char at I. Okay, but because I is going from the end to the front, it's going to take the letters from the end and go backwards. All right, and then here, what's going on here? Oh, okay, I got an extra bracket. There we go. So then at the very end of this, we're just going to print out B. Okay, and you'll see that it's basically the phrase backwards. And here it comes, wait for it, and there you go. That's a lot easier to write the program than to type it out manually in the answer sheet. Okay, and I think there's one more example. Yeah, so then this other example here is, it's not as exciting or as interesting, but I wanted to bring it up because when we compare one string to another, instead of using equals equals, we use dot equals instead. Okay, so for example, like in our code from the past, I might say something like, if yes equals answer or something like that. Remember we did the math tutor and we used double equals to compare what the person thought the answer was to the answer that was generated from the question. So we use double equals. Now in the world of strings, instead of using double equals, we use dot equals. Okay, because it is an object and comparing one object to another, double equals won't work. It only works for primitives. Okay, so and it comes up a lot. Like if you want to log in with a username or a password, and you want to see if if the person logged in correctly, then you want to use dot equals to see if what they typed in equals what their password should be. So it's not an exciting thing, but it's kind of a big deal. Like it gets used a lot in strings. Okay, so I'll just type out what it says here. I'll say if actually, you know what? I can probably copy and paste this code. I should have been doing that all along actually, but it's good practice for you guys. So I'll paste it in here. Now when you do that, it doesn't like these quotes that come from a Word document, so you have to replace them with normal programming quotes like that. Okay, and when you copy and paste it like that, it kind of messes up the formatting, right? But in BlueJ, you can do auto layout, and it'll just fix it all for you so that it looks nice again. All right, so we're saying if phrase equals the quick brown fox, which it does, then it's going to print jumped over the lazy dog, else it's going to print went home to bed. Okay, but because it equals this, then it's going to print. So we're going to see jumped over the lazy dog, basically. If I compile this and I run it, and you'll see that here. I'm just going to take a pause, sip my tea. There you go, jumped over the lazy dog. All right, so we've looked at, in this little worksheet here, a total of, I think, 5 different string abilities. So actually, we're not quite done yet, are we? So let me just first put this in. Jumped over the lazy dog. I'm getting ahead of myself here. All right, so there is one more, replace all. This is sort of a last minute one. I thought, well, that's kind of a cool one. Like, let's replace all foxes with dogs, okay? And we can't use B because we're using B already up here. But let me just type that out and maybe just modify it slightly. Where am I going? Here we go. Okay, so I'll just go like, I don't know, string S equals phrase dot replace. So we're going to replace, replace all fox with dog. Okay, so now instead of saying the quick brown fox, it's going to say the quick brown dog. Not until we print it though. So I'm going to go print line S so we can actually see that. So I'll just compile it and we'll just run it this last time here. Okay, so then you're going to see the quick brown dog. Okay, now the reason it's on the same line is because the previous example I was using prints instead of print lines. Okay, now replace all really does replace all. Okay, so there was only one instance of fox in the string, so it just found the one thing and replaced it with fox. Okay, actually I think this entire phrase though there's no duplicates, I don't think, is there? The quick brown, oh yeah, there's the O here and the O here. So I could say the quick brawn fax if I want to. Replace all O's with A's. Okay, and then we can do that instead. So it will replace everything it finds. So we can just do a single letter. So we're going to look for an O, and we're going to replace it with the letter A. Okay, now it is case sensitive, so it will just replace lowercase, but that's okay. But just want to show you that it will actually do more than one if it finds more than one. Okay, so now it should say the quick brawn fax. That's hard to say. Brawn fax. Okay, I guess that kind of makes sense. I don't know. Anyway, so there you go. Now we have our sort of complete short list of Martin's approved string methods that I think you'll find useful in your life to come as a programmer in Java, or in any, like all languages, guys, have string functions, not just Java. Okay, so every language you will learn has a way you can play with your strings and do different things with them. All right, so we looked at the length, we looked at substring, 2 uppercase, 2 lowercase, index of, and char at. I find these are kind of opposite each other. So index of is like what location is C at? And here I'm saying give me the letter at this location. Okay, so we're getting a letter back from a location. Here we're getting a location back from a letter. So they're kind of opposite each other. It's kind of a way to look at it. And dot equals to compare strings and then replace all. So the next page of this, guys, is just a summary of that. Okay, so let me just actually answer this one. I haven't done that yet. So the quick brown dog is what that one produces, right? So on this one here is kind of a summary of what we just learned. Okay, now part of what I want you to realize too is that all of these methods return a type of answer that could be different. Okay, so what I mean by that is the dot length method returns an integer. Okay, and how do I know that? Because the answer I get back is being stored into an integer variable. Okay, so because the length is going to be a number and I want to store that answer, I'm going to store it in an int. Okay, so I'm going to actually put that here using the language of a Java programmer. Okay, so I'm going to literally say returns, okay, which means sends back as an answer. Okay, but from now on I'm just going to say returns because this is what I mean when I say returns. I mean sends back as an answer. And integer representing the length of a string, okay, including spaces, if I spell that right. Okay, so that's what that does. Okay, but the other string methods return different kinds of answers, right? So for substring, what are we getting back? We're getting back part of a string. Okay, so because we're getting back a string, it returns an answer that has to be stored into a string. Notice I'm not using int s here, I'm using string s because of the kind of answer I'm getting back. So here I would say returns a string that is part of the original string. Original string. Okay? Excuse me. But we also have to say, we have to provide the start number and the number 1 past the end. Okay, so remember this is going to give me back 2, 3, 4, but not 5. Okay. Also, remember numbers start at 0. I'm going to fix that. Remember numbers start at 0. Okay, so the location number starts at 0. Okay. Another thing that I should talk about when we're talking about methods is not just the return type. Like we get an int back here, we get a string back here, but also what goes inside the brackets when you call that method or when you ask for that command. Okay, so some commands require nothing. So when you're asking for the length of a string, you're not sending anything in. You're just going length bracket bracket. If you want a substring, well, you got to provide 2 numbers to get that substring back, right? So start and end. There's also a version of substring where you only supply 1 number. Now we didn't look at this on the other page, but I wanted to definitely include this one as well because it gets used quite a bit. Okay, so basically this also returns a string starting at the given location. Okay, and we'll say since you are only supplying 1 number, I can talk faster than I can type. It goes from that location to the end. Okay, so we're saying give me a string starting at location 6, and because I didn't supply a second number, I'm also allowed to call the method this way and give me from there to the end. Okay, so it's kind of a shortcut. Okay, some of these other methods that we call require, like, say, a letter, so, or a word. Okay, so index of, we can supply a letter, or anything else, like in double quotes we can also do. We'll get to that one in a second, but for to uppercase we don't supply anything. So basically this returns a new string with all the letters converted to uppercase. Okay, so that's what this one does here, pretty straightforward. And just again, another reminder, there's also a dot to lower case. Okay, so capital L, lower, capital C, case, like that. Okay, it does basically the same thing. Index of CHR basically returns location of supplied letter. So with this one you have to supply a letter or a word, or word. Okay, so starting location, I'll say, because if it's a word, obviously it takes up more than one location. Okay, but if it's just a letter, it just takes up the one location, right? You know what I mean. What else do I want to say about this? I also want to say if it returns a -1, then what you were looking for was not found in the string. Okay, it's kind of a wordy way of saying it, but you get the idea. And also look at the return type. So the return type of index of is an integer because you're getting back a location, right? So the location is a number. So notice I'm using int a to capture the answer I get back when I call this method. Okay, char at basically returns the char. So this one has a return type of char. Notice to call this, I have to have a char variable to receive back the answer. So it returns the char found at a given location. Okay, so you need to supply an int which is within the location of the string, right? Which makes sense. I'm not gonna, just gonna fix my spelling here. I'm not gonna give a number that doesn't exist in the string. Okay, and in fact, if you do that, you're gonna get an error. Like it'll throw some kind of a error that says like string index out of bounds because your number's out of bounds of what the string is. Okay, so dot equals. Now dot equals on its own, guys, because we're using it in an if statement, some of you might get this, but some of you probably won't. This means we're returning a Boolean, okay, because we always put Boolean, like true-false expressions inside of an if statement like this. Okay, so basically it returns true if two strings match, or false if they don't. Okay, and basically you need to supply another string. Okay, so when we use dot equals str2, that has to be a string. Okay, and we did that up here, right? So dot equals another string. Okay, and because this entire phrase equals returns a true false, I can shove it right into an if statement. So I can call the method in an if statement and it'll return right to that spot a true or a false, and then do whatever it needs to do depending on whether this is true or false. All right, and the last one, replace all old new. Okay, so basically with this one, you're getting back a string, so it returns a string, a new string, with all old strings replaced with new ones. Okay, so it returns a new string. So notice so basically you need to supply two strings for it to work. Okay, so with all these methods, guys, two things. You need to know like what has to go into it and what you're getting back out of it. Okay, this is going to become a big theme for future lessons as well, but for now, hopefully you understand, like when you're calling replace all, it won't work unless you put two strings in here. Okay, it also won't work unless you're getting, like, you're setting it equal to another string that you're going to use to receive the answer. Okay, now with all of these guys, everything you get back returns a new string. So in none of these things that we've done is the original string phrase ever changed. Okay, so like over here, we did lots of things to phrase, right? We got the length, we changed to uppercase, we got a substring, index of, etc., spelt it backwards. Okay, but through all of this, phrase remains unchanged. Okay, and that's the way strings work. Like once you make a string, um, you can't necessarily change it with these string abilities. It just basically sends back an answer based on the original string. Okay, and to prove that, down here at the bottom, I'm going to finish off with c.println, and I'm just going to print phrase one more time, just to show you that through all of this, phrase never changed at all. Okay, some of you may have gathered that, but maybe you didn't know, so I thought I would make a big deal of it at the end of this lesson. So there it is. So the quick brown fox. So that's the original phrase after we did the replace all with the quick brown fox. But remember this version, the brawn fax, it's hard to say, that's stored into a different variable, right? Because we said string s equals phrase.replace all O and A. Okay, so the quick brown fax is my string s, and the quick brown fox is my original string, which is called phrase. All right, so hopefully that is all good and well. Now we're not going to do any assignments to follow up with this week because you've also got a quiz on your plate that I want you to do, which is from the other video. And then next week we're going to focus on doing some actual programs. We'll do like 3 little consoles, and then we're going to do Hangman as our big p-applet of the week. So can't wait for that, but that'll be for week number 6. So that's all for this week, guys. When you go to submit this, I want you to oh, I should cover that too. I want you to download this as a PDF file. So first of all, you're going to go File, Download as a PDF, okay? And so it's going to come down as a PDF to your computer. So there it is right there, right? And if you open this up, you guys know what PDFs are, right? They're basically just a print of your thing. Make sure you put your name on it. I didn't put my name on mine. Now it might spill over to a third page. I don't really care about that. But this is the thing that you're going to be submitting to the Dropbox, okay? So you can show it in your folder or in your Finder. So you're going to submit this and your test the same way. Download as a PDF and you're going to submit that. Also submit this little dinky program we did, okay? Because I just want to see that you did a little bit of coding this week with me and that you sort of experienced firsthand the beauty and wonder of string methods. So I'll be asking for 3 things next week, or this week rather: the string sample program, the string discovery sheet PDF, and the quiz PDF. All right, so get busy, get all that done. Have a good week, and we'll see you again next week. Bye for now.